Hello everyone. The title of this video is Section 6.4 Part 2 on choosing a factoring strategy. So in this video I'm going to be going over a version of the Knewton Alta assignment for Section 6.4 Part 2. Please know that the version I'm going to be doing, the questions I'm looking at in this video, are not necessarily going to be the same questions you'll see when you work on Section 6.4 Part 2. Alright, but the objective will be the same, the types of questions will be similar, the way you would go about working on them would be the same. So I'm hoping that watching me go through these several examples help you out in some way when you're working on the assignment on your own. So here is the assignment page. Now you won't be seeing the word preview, you're just going to see the title of the assignment, the mastery bar telling you how far along you've gotten, and then here are the objectives. Now this particular assignment only has the one objective, which is use a general strategy for factoring polynomials. Then we have our questions, and every question has a feedback button where you can send feedback to Knewton. If there's like typos or whatever, something, you can contact Knewton. You will not have the instructor cheat button, right? That's just for instructors. And then you have the more instruction button, which is useful for if you want to see some extra reading material or videos that will maybe help you with whatever objective or question you're working on. Alright, so as I said, this is the only objective, right? A general strategy for factoring polynomials completely. So before I get into this, I actually have pulled up here the openstacks.org Intermediate Algebra 2nd Edition and section 6.4 on the general strategy for factoring polynomials. And in that section they have this little box here, which is a nice little, taking you through what you should be thinking of when you're given a polynomial to factor. Alright, so the first thing on top here, see GCF, means you look at all the terms in the polynomial as is, and you factor out the greatest common factor, if there is any. Alright, then after that, you ask yourself, how many terms does the polynomial I'm looking at have? If it has two terms, right, that's called a binomial. The only way you're going to be able to factor it after the GCF is if it's a difference of squares, a sum of cubes, or a difference of cubes. And they got the little formulas here, which I've put up in previous videos, so I'm not going to rewrite them. Now, don't forget that a sum of squares does not factor, right? Only a difference of squares factors, and then sum of cubes and difference of cubes factor. Alright, well that's if you have two terms. If the polynomial has three terms, and it's one of those, special quadratic trinomials, ax squared plus bx plus c, or ax squared plus bxy plus cy squared, something like that, with either one variable or two variables. Then it can be factored either using the AC method, which I'm not going to discuss. I have discussed that in previous videos and previous assignments. I'm hoping you know what the AC method is. And up here you got if the lead coefficient is 1, it's pretty simple. Again, if you'd like, you can actually go back through Chapter 6. The entirety of Chapter 6 in the Intermediate Algebra 2nd Edition book is on factoring methods. So go into Section 6.2 on factoring trinomials if you are unfamiliar with or need to refresh yourself on what the AC method is and stuff like that. Then if it has more than three terms, right, 4 or more terms, try factoring by grouping. And once again, I'm not going to go into as much detail in this video because I've done it in previous videos. But if you'd like, again, you can go back to section 6.1 if you want. There, they go into more detail about factoring by grouping. Right, and they also have, even below that, a how-to, right? Basically, they're taking this box up here and putting it into, again, steps. What's the greatest common factor? Factor it out. Do you have two, three, or do you have 2 terms, 3 terms, or more terms? And then, what you should be doing in each of those cases. And then, of course, at the very end, you should be checking your result by multiplying the factors you got, multiplying your final result. And if you're multiplying properly, hopefully you get back the original polynomial. And if you don't, that means you either factored wrong or you multiplied wrong. Okay, so yeah, I just wanted to go over that there because I didn't want to write all that stuff again. Alright, so I'll write this polynomial out. We have y to the 6th power minus 1, and we're asked to factor completely and put the answer in this box down here. Okay, so I'm going to talk out loud the little steps for factoring. First was, look at the terms. Is there a greatest common factor other than 1? And no, the greatest common factor of these 2 terms is just 1. 1 goes into everything. So I'm not going to pull out a GCF. All right, there are 2 terms. Right, there are 2 terms. Now the only expressions you're going to be able to factor with 2 terms are differences of squares, sums of cubes. Well, this is obviously not a sum, right? It's a difference. Or differences of cubes. Well, this first term, y to the 6th, 6, the power of 6, that's a multiple of both 2 and 3. So I could think of this as a different, and 1 to any power is 1. 1 squared is 1, 1 cubed is 1. So I could think of this in 2 different ways. I could think of this as a difference of squares. We have y to the 3rd squared. Remember, when you raise a power to a power, you multiply them. That's y to the 6th. So here's y cubed squared. There's a square. Minus, and then, like I said, 1 is just 1 squared. All right, same thing. So you could think of it as a difference of squares or y to the 6th, that's the same thing as y squared to the 3rd, a cube. Minus, and then 1, I can write 1 as 1 to the 3rd. I could also think of this as a difference of cubes. Now what I'm going to show you is that for this one, no matter how you look at it, when we're done factoring completely, they're going to have the same factors. Alright, so remember how a difference of squares factors, a squared minus b squared factors to a minus b times a plus b. So the a here is y cubed, the b is 1. So we have y cubed minus 1 times y cubed plus 1. Alright. Then this factor here, y cubed minus 1, that's y cubed minus 1 cubed. Alright, 1 cubed is 1. So this is a difference of cubes. And then this second factor, y cubed plus 1, well, that's the same thing as y cubed plus 1 cubed, right? 1 cubed is 1. So this is also factorable. This is a sum of cubes. And again, I'll leave the formulas to you to look up. So this difference of cubes, y cubed minus 1, that'll factor to y minus 1 times y squared plus y times 1, just y, plus 1 squared, which is just 1. That's the difference of cubes, how that would factor. Then the sum of cubes, y cubed plus 1, would factor to y plus 1 times y squared minus y times 1, or just y, and then plus 1 squared, or plus 1. And there you go. Here are the 4 factors of this y to the 6th minus 1 that we were given. Right? We've got a factor, y minus 1, a factor of y squared plus y plus 1, a factor of y plus 1, and a factor of y squared minus y plus 1. All right. Now, let me show you, that for this example anyway, right, and really just this example here, this doesn't always happen. You can't always look at it in 2 different ways. But when you can, I should end up with the same 4 factors over here when I start thinking about the original as a difference of cubes. So y squared cubed minus 1 cubed, right, as a difference of cubes would factor to y squared minus 1 times, and then y squared squared, that would be y to the 4th, and then plus, y squared times 1, or just y squared, and then plus 1 squared. Right. Okay. And then y squared minus 1 here, this is a difference of squares, right? Y squared minus 1 squared. Alright, now this actually, you know what? Now that I'm doing it this way, it would be better to start off with difference of squares here. Because I can factor the difference of squares fine. Y squared minus 1 squared, that would factor to y minus 1 times y plus 1. Cool. So you see I have the factor of y minus 1 in both of these, factor of y plus 1 in both of these. It's this factor here that would actually be a lot trickier. Y to the 4th plus y squared plus 1 should factor to these 2 factors here. The y, it should factor to y squared plus y plus 1 times y squared minus y plus 1. And you could test that out just to be sure. If I multiply these 2 together, distribute the y squared, we have y to the 4th minus y cubed, and then plus y squared. Then distribute the y, we have another plus y cubed minus y squared, and then plus y. And then distribute the 1, we get plus y squared, and plus y squared minus y, and then plus 1. And putting everything together, we'd have y to the 4th, no y cubed, we have 1y squared, no y, and then 1 itself. So indeed, that checks out, but that one, that's hard to see. This is a trinomial, sure. Y to the 4th plus y squared plus 1, it's a trinomial. But if you tried factoring it by the AC method, 1 times 1 is 1, there are no factors of 1 that add up to 1, so you couldn't factor that by the AC method. So yeah, I'd be hard-pressed to find a way to factor it that way. So this looks like the better way, because I can, that where I started off looking at it as a difference of squares, when I started looking at it as a difference of squares, I ended up being able to factor completely without any difficult polynomials showing up. So here's what I got in the box, right? Here's what I got in the box, these 4 factors. And that's what I'm going to type. I'm going to type those 4 factors back in the problem. All right, so one factor was, y minus 1, and just make sure you're using the correct variable. One of the other ones was y squared plus y plus 1. And another factor was times, y plus 1. And the last factor I had was y squared minus y plus 1. Okay. And let me submit. Great. Yeah, so that one was a lot easier to look at as a difference of squares first and then factor from there. Because looking at it as a difference of cubes, and that's what they're doing here too. See, looking at it as a difference of squares first. And please remember that after every question, there is an answer explanation, whether you get it right or wrong. If you get it right, just glance through the answer explanation. Make sure you got it correct for the right reasons, that you didn't just get lucky. Or maybe that they present an alternate way of doing it that you didn't think about. That might help you in the future. Now, especially if you got it wrong, look at the answer explanations, and see if you can figure out why you were wrong or where you went wrong, and try to learn from your mistakes and use that to your advantage in the future. All right. So, next question. Again, I'm going through the same procedure. I'm going through the same strategy each time. All right. So here we're given another two-term polynomial. And let's go through and factor it. Again, I'll write this out and we'll factor completely. Alright, so again, first question I ask myself when I'm asked to factor any polynomial is what is the greatest common factor, if any? Now, again, if there is none, it's 1. If the greatest common factor is 1, you're not pulling anything out, and there's nothing common to both these terms. Then you count the number of terms in the polynomial you're trying to factor. Again, I have a two-term polynomial. And the only way you're going to be able to factor a two-term polynomial is if it's a sum of cubes, a difference of cubes, or a difference of squares. Well, this is definitely a difference. So the only way I'm going to be able to factor this is if it's a difference of squares or a difference of cubes. Now notice my exponent here this time is 4. That is not a multiple of 3. So it can't be a cube. But it is a multiple of 2. So I have a square here. That k to the 4th is k squared squared. Right? That would be k to the 4th. So here it is as a square minus, and then 16 is a nice perfect square. That's 4 squared. Right, so I do have a difference of squares. Right, I'll put diff of squares. And again, I'm hoping you remember how to factor these. Right, so this would factor to k squared minus 4 times k squared plus 4. So I factored it, cool, right? But is it factored completely? Is it factored completely? Well, look at each factor individually. The first one, k squared minus 4, that's another difference of squares. Right? That'd be k squared minus 2 squared. So I can factor that. Now the next one is a sum of squares. And if you recall what I said earlier, sums of squares won't be factored. Right? You can't factor those over what they say is over the integers. Right? I can't factor it so that all the coefficients are integers still. But I can factor this difference of squares to k minus 2 times k plus 2. Right, and then the sum of squares does not factor any further, so I still have the factor of k squared plus 4. Alright, great. And there we go. And none of these factor any further. That's factored completely. And again, don't forget to check. I haven't been checking because I know I'm doing things correctly, but be sure to check your answer if you're unsure. Multiply all the factors. If I multiply these two, I'll get k squared minus 4. and then I'll multiply these and get k to the fourth minus 16, right? When you multiply properly, the original should be the same expression. All right, so now I'm going to type those three factors in. And again, be careful to use the same letters. Right? Don't use x all the time. We have k minus 2, k plus 2, and then k squared plus 4 as the three factors of that product. All right, great. And again, please read the answer explanations where again they're going through the questions you should be asking yourself, and then of course checking the answer at the end. All right, so this time, look, we've got 4 terms. 4 terms. So let me write this out first, right, and then we'll talk about the strategy. Ask myself some questions. Alright, so first question is always, is there a greatest common factor other than 1 that goes into all the terms? Well, if I look at all 4 of these terms, right, there's nothing but 1 that that goes into all these. There's no other common factor. Alright, now I notice that this has 4 terms. That's more than 3 terms. So we're going to do factoring by grouping. All right. Now, I've done factoring by grouping in previous videos. In assignment 6.4 part 1, if you watch that, me work on that assignment, all the grouping there, I took polynomials with 4 terms and wrote it as a sum of 2 groups of 2 terms. But that's not the only way to group. Right, you could try it. You could try this grouping, where I put the first 2 terms in a group, 9x squared minus 6xy, and then a big plus sign. We're adding 2 groups together, right, plus, and then the second 2 terms in a group, y squared minus 49. And then remember what you did after that. You factor each half completely. Each group completely. This first group has a common factor of 3x, and if I pull out 3x, then there'd be 3x minus 2y left over, plus, and then y squared minus 49 is a difference of squares. That's y squared minus 7 squared, so that would factor to y minus 7 times y plus 7. But look at this now. These 2 products, right, when you factor the first group, factor the second group, these have no common factor other than 1. Everything has a common factor of 1. That means this is a bad strategy. Breaking it up into 2 terms and 2 terms. But you can break it up other ways. Right? You don't have to always group 2 terms and 2 terms. Another way to group it up, another way to group. So another grouping over here. How about instead of the first 2 and the second 2, how about the first 3? I'll put those first 3 terms in a group. 9x squared minus 6xy plus y squared. And then, the last term is on its own, minus 49. No real reason to put parentheses around that because it's just a single term. So now we factor each group complete. 49 is 7 squared. Let's focus on this for now. I'm going to focus on this expression. So I'll write it over here. We have 9x squared minus 6xy plus 1y squared. Now, if you recall from section 6.4 part 1, remember I said anything like this of this form, ax squared plus bx plus c, or ax squared plus bxy plus cy squared, right, with one variable or two variables, anything of this form, you could try that AC method to factor it. All right, so I'm going to do that here. That's in one of these forms, this form with the two variables. So first I'll take a times c, that's 9 times 1, which is 9. And then I'm thinking of a pair of factors, right? What are some factors of 9 that add up to -6, that add up to b? That would be -3 and -3. So I use these two numbers, -3 and -3, to rewrite the middle term. So we have 9x squared minus 3xy, plus, I like to have pluses because I'm going to be doing grouping again here, plus -3xy again, right, using -3 and -3 to make -6xy, and then plus y squared. Then I have the two groups of 2. Right, this one I'll do with two groups of 2. The first group, pull out 3x, and you'd have 3x minus y left over. Second group, I'd pull out minus y, right? So plus minus y, I'll just make minus y. And if I do that, I'll have 3x minus y. And then they both have 3x minus y, so 3x minus y comes out, and then what's left over is also 3x minus y. Alright, but there's no need to write the same factor twice. Right? This is the same factor twice. It's 3x minus y times 3x minus y. So another way to write that would be the quantity 3x minus y to the second power. So this is a square. 9x squared minus 6xy plus y squared is a square. It is the quantity 3x minus y to the second. Minus, and then 49 is 7 to the second. Hey, look what I have now. Something squared minus something else squared. I have a difference of squares. So remember, like a squared minus b squared factors to a minus b times a plus b. So this will factor to a minus b, 3x minus y minus 7, times a plus b, 3x minus y plus 7. And there you have it. There's our original expression. Right, there's our original expression written as a product. 3x minus y minus 7 times 3x minus y plus 7. Wonderful. Okay, and again, you can test it out. Distribute the 3x, distribute the minus y, distribute the -7 to these three terms here, and combine like terms. You should end up with our original expression. And I'll leave that to you to check, but I'll put a check mark. Remind you, check your answers. Alright, so let me enter those. So yeah, the lesson here is that when you're factoring by grouping, you don't have to cut it in half. You don't have to do 2 terms and 2 terms. You can have groups of 3 and 1, or 1 and 3, if you have a 4-term polynomial, and then factor that by grouping. So grouping is very versatile. So I have 3x minus y minus 7 times 3x minus y plus 7. There are 2 factors. And once again, please read through the answer explanations. And probably the final question here. Okay, we're asked to, factor this completely. Polynomial expressed with 4 terms. That's more than 3. So once again, I'm going to do grouping. Alright, so start the strategy over. Alright, first question. What's the greatest common factor of all the terms? Well, this time, 3 goes into every single one of those coefficients, and that's the largest number. And then that's it. That's all they share as a common factor. So first I will factor out 3. Now if I do so, the other factor would be 5pq minus 5p plus 4q minus 4. And you can check by redistributing the 3 and you get the same thing back. Now I'm going to focus on this factor. And I'll write it off to the side. 5pq minus 5p plus, and then 4q minus 4. And then I pull out the GCF already. Now I notice that this has 4 terms the way it's written. So I'm going to try that factoring by grouping. Now this is one that will work where you break it up into groups of 2. So here's a group with the first 2 terms, plus here's the group with the second 2 terms. I factor the first group, you'd pull out a 5p. And if I did that, the remaining factor would be q minus 1. Plus the second group, have a common factor of 4. Pull the 4 out. The remaining factor, q minus 1. And now look at the left group and right group's factorizations, right? They both have q minus 1 as a common factor, so I pull q minus 1 out. And when I remove the q minus 1 factor, what's left is 5p plus 4 as the other factor. And so there we go. So, and don't forget the 3, right? So this original polynomial I started with, pulled 3 out first, times this 5pq minus 5p plus 4q minus 4, and that factors this way, times q minus 1 times 5p plus 4. And there you go. That is as factored as that's going to get. And don't forget to check. Again, multiplying these two should give me this, and then distributing the 3 should give me the original. Right. Alright, so going back, that is what I will enter. Now, I only did 4 questions here, right? And like I've mentioned before, these aren't going to be the same 4 questions that you're going to see, or the same questions you're going to see. So just pay attention to the strategy, right? You're asking, what is the greatest common factor? If it has one other than 1, pull it out. Then look at other factors and see, does it have 2 terms or 3 terms or more terms? If it's got 2 terms and it's a difference of squares or a sum of cubes or a difference of cubes, you should be able to factor it. If it's got 3 terms and it's one of those special forms I pointed out earlier, the ax squared plus bx plus c, or ax squared y, plus bxy plus cy squared, should be able to factor it or try factoring it using the AC method. And if it's got 4 or more terms, try grouping. Right. So I haven't gone over every scenario. You may see different scenarios, but you should be asking yourself those same questions every single time. Alright. And again, the objective here is the same. The kind, the questions I'm asking myself, the strategy I'm using is the same style, the same, you're asking yourself the same questions every time. And I'm hoping that watching me do just these few and go over the method, the strategy, helps you when you're working on this assignment on your own. And thank you very much for watching.